Hello, and welcome to Game Revolutions, the series where we explore 1980s era techniques for writing arcade-style video games by writing our very own Moon Patrol clone for the Coco. In previous episodes, we got our lunar rover to animate, jump using real physics. I'm not a physicist, but I did take Intro to Physics that one time, and I can attest that if a lunar rover could jump on the moon, it would look exactly like that. Stack blasting to scroll the ground and mountains at different speeds. Shooting. Hit detection. Exploding aliens. Exploding cars. Hyper-realistic cosmological imagery. I'm not an astronomer, but I did watch someone look through a telescope that one time, and I can attest that that is exactly what the Earth looks like from the moon. Pinball-style scoring. Poking holes in a big boss's rotating shield. And much, much more. If you'd like to catch up on previous episodes of Game Revolutions, there's a link to the playlist in the description. Today, as our player tries to defeat the big boss, we put a time limit on them in the form of a quantum ray. I'm not a quantum physicist, but I did watch a Marvel movie involving the multiverse that one time, and I can attest that it is possible for moon-invading aliens to build a quantum ray which, when aimed at a celestial body, will pull an alternate version of that body into our universe to slam it into the moon. It's just science. If the player allows the quantum ray to reach the Earth, our player is doomed. We'll talk about the 3 steps to smoothly animate a falling Earth, watch it fail, and fix problems one by one with help from a little debugging. So we're going to handle the quantum ray using 3 variables. We're not going to extend the ray on every frame because that would make the ray just grow too quickly and we would have no time to shoot down the boss. So this first variable counts down how many more frames before we extend the ray 1 more pixel. And we'll initialize that to 10. So every 10 frames it will grow 1 more pixel. The next 2 variables keep track of how long the ray is. We're splitting the length into 2 variables because one is going to tell us how many full bytes long it is, since on the Coco in this display mode, each byte will store 4 pixels. And then this keeps track of the remainder pixels, so after all of the full bytes, how many pixels within that final byte should be lit up. Since I'm doing double buffering, I also need to keep track inside each buffer what I've drawn so far. So I have the structure of buffer info, and I have 2 instances of that structure. So I've added a couple bytes in there to keep track of how much of the ray has been drawn into each buffer. This helps me to know within each buffer if I still need to draw another pixel so it can catch up with the real state of the ray, or if it's actually already drawn what needs to be drawn. So when it comes time to draw the quantum ray, the first thing I do is I ask, did my current buffer already draw the ray to the length that it's at? If not, I jump to this portion of the code that allows this buffer to catch up to how long the ray is supposed to be. And it'll just draw it from the left side to as far to the right as it needs to be the right length. So I have 1 loop to draw the full bytes, and I've defined some constants here that keep track of what colors each of the bytes need to be based on which row of the ray we're at. I'm going to have like a sandwich with yellow as the bread and red as the meat, kind of like at McDonald's.
Holy cow! God, that is a big burger.
After that loop draws the full bytes, then I just need to draw the remainder pixels, which is just 1 more byte afterward. And these are the bit patterns I'm using. I'll just index into each list based on how many pixels are left to be drawn. You read this list from right to left. So here I'm just drawing 1 pixel, with the rest of the pixels all being blue. Here I draw 2 pixels, with the rest blue. 3 pixels. The reason I do those in reverse is so that I can decrement my index into the remainder pixel list, and when that goes down to 0, then I know it's time to increase the number of full bytes of ray to draw on the left. Doing a decrement like this allows me not to have to do an extra compare instruction to see, for example, if I were going up, if it hit 4. This way I can just go down, and then the condition code z bit will automatically be set when the B register goes down to 0. No extra compare needed. If we didn't actually need to draw anything into the buffer because the buffer already drew the ray at its current length, then I just do some bookkeeping with the state. I decrement my countdown, and if it hits 0, I'll reset the countdown. And this is the code I just showed, which increases the length by 1 pixel. Huh, okay. This is actually a bit better than the first attempts usually go. Nothing crashed, but it grew all the way out to the end. I found a couple bugs, but I think the big one is right here. I was using A to count how many of the full bytes of the ray I needed to draw, but I trashed A over here when I was adjusting the countdown. So I'm just doing a quickie save and restore around that, so that when I go down here to change the length of the ray, my A will be intact for when I store the full and remainder bytes back into memory. Oh my gosh. Okay. Hardly better. Oh, this one is so stupid and embarrassing. I had code to skip over the drawing loop if there was nothing to draw, but there's nothing to draw when A is 0, not non-zero. There we go. Yes, it's starting too far to the right. That's a simple tweak. I was just kind of guessing it with the constants. I'll fix that. But here we're going pixel by pixel. I think it looks pixel by pixel. There we go. Okay. All right, I cleaned it up a bit. Let's take a look. There we go. You'll notice I also added a bit of a cap at the end of the ray. So it kind of comes down to a point. Looks like it's starting at the right place. For the next part, I want to animate the Earth falling down. The quantum ray will pull an alternate Earth into our universe, leaving this Earth here, but causing the alternate Earth to be superimposed on it and falling down to the ground. Right now, the code to draw this only happens once per buffer. On startup, we draw all the static regions of the screen, like this yellow stripe and the blue sky, this green area, most of the ground that doesn't change, and the Earth. And it's hard-coded to appear in this part of the screen. So what I want to do is to parameterize it so I can draw it anywhere. So here's the new code I have, and I've divided it up into 3 phases. Since this will be called as part of animation, the very first phase is to erase the Earth where it was. Wherever the last point was that we drew it on the screen, we're going to erase it by using a block of bytes that we captured before we drew it. So we're going to erase it not just with blue, but if it were like falling down here, then we would know, oh, it was over this part of the mountain or this part of the green. Each of the 2 screen buffers knows 2 things. It knows where we last drew the Earth on this buffer, and it has a pointer to a block of bytes that were the original bytes where the Earth was just before it was drawn. And that's what I used to erase it. I'm going to reuse some of my code that does stack blasting, and I will stack blast that original buffer onto where the Earth was now, using this simple routine that will do 1 row of 5 bytes. Copy 5 simply does a pull and then a push, grabbing the bytes to draw and then drawing them, and then self-modifying code to jump back. Remember, since I'm using the S register as part of my stack blasting, I can't use it to branch to a subroutine and then return. So I have to set everything up. I do the stack blast, I go to the next row, and I repeat. With phase 1 done, phase 2 needs to fulfill that promise by grabbing the original bytes as they are now, where I'm about to draw the Earth in its new location. That way, next time around, I'll be able to erase it just like I erased it now. And being the lazy person that I am, I don't want to go through the trouble of doing that yet until I can see the whole thing kind of working. So right now, I'm not going to preserve the bytes, which means that phase 1 is really going to be erasing the Earth with a rectangle of garbage. And that's fine. I will expect that. I will see that. I just want to see the Earth falling down. And if it leaves a trail of garbage behind it, no big deal. Finally, the 3rd phase draws the Earth at its new location. Once again, I set everything up. Now my source buffer is the set of bytes that draw the Earth, and my destination buffer is the screen. and I loop through my stack blasting to draw every row of the earth. And for now, the only place in the code that actually calls draw earth is the stuff that runs on startup, to just draw the earth once per the 2 buffers. So we won't be seeing any animation yet. All I really want to see is that the earth got drawn, and then I can move on to animating. As per usual, all has gone to heck. I don't usually show the debugging, but I figure what the heck, some people might be interested. So I'm going to set a breakpoint at the draw earth routine. And let's just see what happens as we step through here. We set things up for stack blasting. We're getting ready to erase the original bytes. So we're expecting this will kind of populate the earth rectangle with garbage. So let's start checking things out. So X is going to be FF. Does that make sense? Actually, how can that possibly make sense? This off-screen buff info is supposed to point to either buffer info 1, which should be all the way out here, or buffer info 2, which is all the way out here. What the heck?
A few moments later.
So we got to draw earth from this call, which sits in draw static portions. Draw static portions is called for buffer 1 and buffer 2, and it's inside this main initialization. Okay, I think I know what's going on. I don't think we ever initialized that pointer yet. Yes, here is where we, okay, so here's what happened is I never needed to use the off-screen buff info before because I was never erasing anything before. So this routine did not need to run after I initialized this. Okay, yes, okay. This is easy, no big deal. Okay, I found and fixed a few other bugs, and now it works. It's rather unceremonious in that, you know, all we have is what we had before, but this is the nuke code. This is the nuke code that's running, and it's stack blasting the earth in a parameterized way, so we're set up to do the animation, except I still haven't done phase 2, which is where I prime the block of original bytes with what was before, what was underneath the earth before it was drawn, so I have something to erase it with next. I'll take care of that. Phase 2 is now implemented, so my draw earth in phase 1 erases the earth using stack blasting. Phase 2 grabs the bytes underneath where the earth is about to be drawn using stack blasting. And then phase 3 draws the earth in the new location. And so now the code that draws the quantum ray, right now I'm going to short circuit drawing the ray itself and immediately jump to the place where we draw the earth. So the animation doesn't go too fast. I have a countdown like I have elsewhere. Once enough frames have passed, then I'm going to add 32 to the location of the earth. That brings it down 1 row. And then we call our brand new draw earth routine. So we should see the earth immediately falling as soon as it starts. Okay, well, I guess either it fell very fast, but only in one of the 2 buffers, or something else bad is happening. Okay, I found a couple bugs. First off, I wasn't initializing anything. Sometimes I get so excited about new functionality, I forget to actually follow through and do everything before I try running it for the first time. So this is the code that initializes all the boss stuff. And I had to add this. I had to add initialization of where the earth starts. And of course, I had to initialize the countdown with the countdown max. And the other problem was over here, I was trashing my D register. I've done that before, and I seem to just keep making the same mistakes over and over again. I load D with the location of the earth, and then I trashed it here when I was doing the countdown stuff. So first I'm just going to preserve and then restore it before I go ahead and add 32 to move it down to the next row before storing that again. Oh, there it goes! It's falling! It's falling very slowly, and it's leaving a trail of nonsense behind it. I don't understand that, but I'm taking this as a win. You'll also notice, by the way, we get this entire rectangle with blue stuff. I'm not doing any kind of masking yet. I'm going to save that until I get most of this stuff working. But yes, we got this like rectangle of blue around the globe. That's fine. Now we don't have a trail of nonsense. But, oh, no, that's not right. So some of this is not getting erased properly. But I'm taking this as a success. This is the closest we've gotten yet. Down you go. Maybe we can speed it up and see what happens when it goes, yep, boom, it went boom. So here was the problem. This is the line of code that remembers for this buffer where we last drew the Earth in this buffer. And we need to know that so we know where to grab the bytes to save to use to erase it with later. Unfortunately, I wasn't actually initializing X. So I was saving the location not into here, where it should have been saved, but into I don't know where. So this would be self-modified code to load X with the proper pointer. And then up here, we preserve that pointer over here when we have it handy. It's not twinkling. Oh, well, oh, this is weird. Almost like a mirror of part of the screen that's animated. Although if you look carefully, these aren't really animating a full rotation, they're just bouncing back and forth. Probably because we got from one buffer and from the other buffer slightly different points in time. Huh. This is probably better. I've added some code to the initialization so that we prime that block of bytes that we used to erase the Earth with the original Earth. Before, it was actually just garbage, and I thought, oh, no big deal. After the first draw, it'll like get populated properly. But as I think about it, that was probably very foolish. And I just have a very, very, very simple loop to copy from X to Y. Doesn't need to be fast, only happens when the boss first shows up on the screen. And rather than just run this, I'm going to do what I really should do all the time, which is to step through this and to make sure in a debugger that the things are what I think they are. And as a treat for you, you get to follow along. So I'll set a breakpoint in that boss initialization code. All right, so we're here. We're about to start. And we'll just jump back down to here when we start doing the Earth copying. So first I want to make sure that Earth size is what I think it is. And I know the Earth is 37 rows of 5 bytes each. 37 times 5 in hex is B9, so B9 is good. And on the first iteration, we do our load and our store. This line stores it into the first buffer's original bytes, and this stores it into the second buffer's original bytes. So I also wanted to double check that this math makes sense. Earth size minus 2 plus y gives me 5425. And 5425 indeed is where Earth rig bytes 2 starts. Very good. And as I step through this, I'm just keeping my eyes on X and Y just to make sure they're both basically going up by a couple each time. Okay, that seems about right. So let's watch. You know, sometimes you have a bug and then you find a problem and you fix the problem and it makes no difference, but the reason is not because it was a bad thing to fix. It needed to be fixed, but there's just something else out in front of it, some other obstacle that before you even got to the bug that you fixed, you still have to push through the other bug that you haven't fixed yet, but that's causing the thing that you're seeing right now. It's fine. Well, I did find one thing I needed to fix, which is all of that code that initialized that block of bytes that I used to erase the Earth with. I really should be doing that on startup and not just as soon as the boss is drawn, because I do call the draw Earth routine on startup as well. I should have all of this initialized before I ever use it. That was just kind of dumb. I am still not, I don't think this is going to do it. We'll try it, but I don't think this is going to be it. Yeah, I'm going to speed it up. Yeah, it's the same thing. Okay, So I'm just going to double check everything is called in the right order. So this is where I initialize that block of bytes. This is where I use it. Let's just make sure that as we start up, those things actually happen in the right order. Yes, so here I am in init buffer infos. So I'm going to go down here. And sure enough, we're initializing the buffers there. X and Y look reasonable. And then when we continue on, now we're at draw earth the very first time. So everything's been initialized. And in fact, I can even open up a memory window and take a look at these buffers. In fact, I'm going to open up 2. So I can go to earth rig bytes 1, earth rig bytes 2. These are both of the original byte buffers. In fact, if you look here, you can kind of easier eyeball that they're the same. And if I compare these buffers with the actual bytes of the earth, looks about right. We have a couple 8As and then an 8A, and a couple 8As and then a 9A. So it looks like they're getting initialized. So I should be erasing them with the right bytes. And if I jump ahead to here, S points to my source buffer, 5388, which is the block of bytes I used to erase stuff with. And U points to 14DE, which sure enough is the location on the screen where I'm erasing to, or at least it looks like it. Pretty sure it's right. So phase 1 should be doing the right thing. If I jump ahead to phase 2, I'm setting up my U register, my S register. So now we're going, this is the part where we preserve the original bytes before we draw the new earth. So we're going from screen, which is here, to the buffer, which is here. 53.8D compared with 53.8.8, but that's normal. We're doing stack blasting. It's pushing stuff in reverse order. So 53.8D should be the end of a row, and then we're going like this. If I do a few more steps, U is now 5392, which should be right around here. S is still pointing at the screen, so that seems right, I think. So to fix this, I had to do some careful math to be absolutely certain I knew exactly where the Earth was supposed to show up, exactly how big it was. Some of this was fine, some of this was not. And I had to be very careful with these fix-ups as I was doing stack blasting, because the different phases have different characteristics. When I'm reading or writing from a buffer, I don't need to skip lines, but when I'm reading or writing from the screen memory, I do need to skip lines. So for example, in phase 1, the destination pointer needed to be adjusted like this, but the source pointer didn't need to be adjusted at all because the polls did it for me. In phase 2, I had to adjust my source pointer by skipping lines and not my destination pointer. In fact, I didn't have to do anything with the destination pointer. And in phase 3, only the destination pointer needed a fix-up. And crucially, so I could retain the original Earth as the new Earth was falling, I had to fix an off-by-1 bug. This -1 was missing. I was erasing the new Earth with just blue. I was erasing with blocks of bytes a bit too high on the screen, and that was enough to make the entire background of the Earth be blue rather than the original Earth that it was supposed to tear away from. Next time we'll explore bit masking to get rid of those pesky blue corners that follow the Earth as it falls.